Hey guys, so today we'll be solving the daily problem. It says separate squares 1. So we are given two 2D integer array squares where we have x coordinate, y coordinate of the bottom left point, this point. Uh, we'll just show it in a minute. And we have the length. So this represents the coordinate of bottom point and the side length of the square. Okay. So we need to find the minimum y coordinate who tells us that all the areas of the squares were divided. Okay, let me show you with an example. Okay, so suppose this is a coordinate. Okay, this is the x-axis and the y-axis. We have one square here, we have another square here, we have another square here. So what the question asks is, we need to find this line y equal to something a, suppose, such that all the area above this sum is equal to this area below this. You can see clearly here it would be something like this. Area above it is this one plus this one, below it is this one plus this one. So we just need to output this. What is given? We are given this bottommost point x comma y. We, because in square, right, we only need one point. You can see if this is a square, we have this point. Then suppose this point is 3 comma 3. Okay, then we also have given this x, y and l is the length, so we can get all the four coordinates with this point. How? Let's see. So what is this coordinate? It's basically 3 plus l comma 3, right? This coordinate, because we are moving 3 steps, l steps to the right. Similarly, this point, again l steps above, so 3 plus l and 3 plus l, right? We incremented l steps to the y coordinate. What is this point? This is nothing but this point, this below point incremented by l steps. It's basically 3 comma 3 plus l. So here we saw that if we got only one point and a length, then we can evaluate all the other 3 points, right? So let's again go back to the question, like how we can solve this problem. So if you can see, we have this. So what we can do on the brute force size is, we can move y from 0. We can check for every particular y. Suppose the current y is this one. Then how we can check is, we can check, we will go to every square one by one and check if that particular square lies below. If it lies below, then what is the area? Area here is nothing but, it lies below, it's nothing but this l into l, right? Again, if it lies above, it's again l into l. What if this current line divides it? Okay, then the below portion would be mid minus whatever the y coordinate into a, because we have this is the medium, this is the middle, the middle minus y would be this, and we will multiply with this particular length l. Let me make it more clear. What is the middle? It's nothing but, suppose this whole thing is this point. One second. This point is y. Okay, this is mid. So what is the above this line? It is nothing but y minus mid. This is y plus minus mid plus the length, right? You can see it clearly. So we already have this point, right? From this point, we need to find it. So till this point, this is y, not this one, sorry. Then we increment it by L to get this point. Then we reduce it by mid. So we will finally get this particular length. Okay. So this length is this one multiplied by this length, which is basically L. So we will get this particular area. Nothing but into L, right? Similarly, what is the below area? The below area is nothing but we can get this middle minus this y. In that way, we got this portion, this line, right? This is y, and this portion is mid. We reduce the y to get this portion. Now it multiplied with this L, so we will get this area. Now we will calculate each of them, and if this particular area of up is equal to the down area, then we got the answer, right? But this time complexity is very high because we are brute forcing it. We will go to maximum of whatever this particular y value is, and if you can see in the question, the value of y can go up to 10 to the power 9. So we can't do brute force here. So what is the optimal solution for this one? Let's see this. So let's see. Let's assume this is a one square, this is another square. Okay. So let's think carefully. Okay. What are the options we have? So suppose this is a particular current mid I'm searching for. So it is very clear that if I move this line up, then the up area will got reduced and the down area will got up, right? So suppose the up area is this one and the down area is this one. So we can adjust this mid at a point such that the difference between up and the down is almost equal to zero, right? So we can move up this midline, then up area is always decreasing. So we can see a monotonous behavior here. As we move up is always going to be decreased and the down is always going to be increased. So we will see a monotonous behavior. So what monotonous behavior leads us to? Leads us to binary search, right? When we can use binary search? When there is a monotonicity. Here the area keeps on increasing the down area when we move up the mid. That definitely means we can use binary search. How we can use binary search? Let's take the lower bound. The lower bound we can start from here 0. What is the higher bound? Higher can go up to, so we are given this x point and y point, right? And L. What is the topmost point? It is y plus L. And if you can see in the question, y is 10 to the power 9 and L is 10 to the power 9 itself. So the higher point can go up to 2 into 10 to the power 9. So to be more safe, we can have 10 to 10 to the power 9 for the high. Okay. Then we will have a check function. So what this check will do, we'll get a particular mid. We will go up to each square. Then we will increment our answer if that particular square is in the lies in the up region. Let's write down the formula. If lies up, so we are lies line up completely, right? Then we can have added this L into L, because this is completely this this completely lies above our particular mid. Okay, if it lies down completely, then again we can have this L into L, but we will decrement in the case of down and increment in the case of up. And other case, what is the other case? Other case is basically this thing, the above thing that we already saw. In the down case, we got this as the formula, mid minus y into L, and in the up case we got this formula, right? So this formula will be positive, this formula will be negative. We already see that. If you have any doubt, you can rewatch this section. Let me again tell you this dissection to be more clear, right? So suppose this is a square and we cut it in the middle. Okay, let's still move this square. Let me draw again. Let's see, if we have this square, we're cutting it at this point, this mid. We have this is x comma y. Okay. We have this point as x comma y plus L. Okay. Okay. Now, what is the area of the below part? This is L. Okay. It is nothing but L into this portion. This, what is this portion? It's nothing but till here it's mid. Okay. Till here it's y. Mid minus y. Right. Mid minus y. If this is below part, so we'll be subtracting this. What is the above part? What is the value of this point? This is nothing but y plus L. We got this point is y plus L. We'll subtract the mid to get this point, right? Minus mid. Okay, and the whole thing is this breadth. Breadth is L. We'll make it positive. So while taking negatives for the below part and positive for the upper part, if we got the overall sum that is less than equal to 0, then our check function for the minus h will return true, because we are finding a value as close as this 0, right? You can see in the question, it's also mentioned that we need to keep it till 5 decimal points. So we will take care of it with an epsilon. Okay, so let's just code it up to get it more clear. Okay, so let's have the epsilon. So const double epsilon is actually 1e 10 to the power minus 5. Okay, get it, get the value as close as 5 decimal points. So we'll have a low that start from 0 and high will be 3 into 1e9. Okay, and there will be an answer which is, at first it, let's point it out to high, and why this low is less than equal to high. So this is the point. So this is what we do generally, but in case of some decimal pointer thing, we will have it like high minus low should be greater than epsilon. So in this way we can have this value up till 10 to the power 5. So high and low can be as low as 10 to the power 5. Okay, so we can have mid is nothing but high minus low by 2. If our particular check function, it's true, then we got the answer. We'll store it and try to have a better lower value, because you can see we need to find a minimum y coordinate. So if we got answer for this mid, we need to check for, we need to reduce our high to mid to check for the lower half. Okay, in the other case we will move the side space above. Okay, so let's have the check function. So this check function will have the double mid, and it will have a sum that's firstly 0, and we will go to every squares, and we will have, suppose the x coordinate is e of 0, y coordinate is e of 1, and the length is e of 2. So if a particular y plus l, what is y plus l? It's nothing but, so this point is y, right? So y plus l is nothing but the upper point. So we'll check if this y plus l lies above the mid or below the mid. Then if y plus l lies below the mid, that means the square is lying, whole square lies below the mid. And if the particular y is lower point, if that lower point is itself above mid, that means the lower point is itself above mid, then we can say the whole square is above mid. Okay, so if that y plus l is less than equal to mid, then we can say the whole square is less than equal to mid, and we can simply subtract the sum. Else if y is greater than equal to mid, we will increment the sum. In the else case, right, we will increment it by upper half, which we already told that this is the formula, into L. Okay, and we will subtract it by what? Mid minus y into L, the lower part, lower half of the dissecting. Finally, we will see if that's less than equal to 0. Right, that's so simple. Let's run it. Okay. You can see this is passing. Let's try to submit this. Yeah, so this is passing. Okay, so as you can see, this is passing, so we can just, so if you have any doubt, you can see this whole diagram again. Yeah, happy to connect more. Yeah, thanks, bye.